Okay, welcome to my Connect session on why Couchbase and why now. What I'm going to do is take you on a little bit of a tour of the history of databases and then sort of talk to you about how I think that relates to what we've got going on at Couchbase. All right, so the plan is give you a little bit of background about me because I'm, sort of saying I'm going to give you history and I'm an old guy, so I want to convince you that it's maybe worth listening to. Then I'll give you a database history lesson, and then I will talk about Couchbase Server and particularly 7.0 and what it brings to the table. And then I'll talk to you a little bit about HOAP for NoSQL. I'll explain when we get there. And then I'll wrap up and take your questions in the online questioning thing that we do afterwards. All right, so just a little bit about me. How old is old? Pretty old, right? So I go back to 1980 at Berkeley when the Ingress project, which was one of the two big database projects, along with SystemR at IBM, was kind of wrapping up. So I wasn't there during the creation of Ingress, but I was there shortly thereafter. And then I spent a bunch of time in universities, at the University of Wisconsin, worked for IBM, for about 5 years on DB2 at a software company during the internet bubble, at another company for quite a number of years doing some integration and data federation things. And these days, my day job is teaching at UC Irvine, and on the side, I consult for Couchbase. But the thing to notice here, as I've been doing databases for about 40 years, so that's where I'm going to be talking to you from, essentially, is from that kind of watching the history of databases evolve and sort of teaching them before they were actually sort of commercially viable necessarily. All right, so if you believe that, then maybe you'll be interested in a database history lesson. So we're going to talk about the evolution of databases, like where did they come from? So in the beginning, there were files, right? So we had operating systems running on mainframes, serving small numbers of multiple users, and data was being stored in files. And whenever anyone had to build something, they would basically build an application, and they'd have to start by overlaying the data they had in their mind, the files, the record structures, sort of on the low-level primitives that files provided. And then along sort of came the realization that we're all spending way too much time, managing records. And so there was the next generation of databases that, again, we're going to sort of double click on that one. So I won't go into too much detail here, but the next generation that really said, okay, we're going to have a notion of record-based files with fields and so on. And then came a game changer, the relational model. And we'll also double click on this in the next few slides. Ted Codd from IBM in 1970 sort of came and gave us a new way of thinking about data that we'll drill into. And of course, now we're looking at the question, like, how do I deal with data today? And there's various proposals for how that should be done. So let's go back to the birth of databases today. So in the beginning was the Word, and the Word was with Codd, and the Word was Codd. Ted Codd, right? So he wrote a paper in Communications of the ACM in 1970 that really changed like the whole landscape for IT. It was called a relational model of data for large shared data banks. And a lot of you are too young to know that this was not the first generation of real database management systems. And so what we're going to do, is sort of look at what was going on before Ted, before Codd. We're going to travel back in time one generation and look at what was there, and then look at what Ted Codd brought to us and what the advantages were, and why relational databases were so successful. And then we're going to move on and talk about what that has to do with databases today. All right, so this is us, right? So the old guy is me, and the younger guy is you, and we're going to get in the DeLorean and sort of fly back in time. So here we are. It's BC, before Codd. Right. So the need for a data management library, the idea of, sort of being able to manage files of records, a database system was recognized. There were hierarchical databases, they were called, like IMS, which was kind of the big gorilla in that space from IBM. There was a standard called Codicil for what was called network databases. And I've got sort of a picture here that we'll drill into in just a second. But these systems basically provided ways to look up and navigate groups of records. So they had notions of files and records and links or pointers between records or sets of records and indexes. They had essentially what they did was to manage that first set of concepts, records with fields as opposed to byte streams and files. So that was a good thing. A lot of effort was saved, and they provided some, sort of support for reading and writing and sort of persisting them and recovering them. And so there was a bunch of work that you used to have to do, you didn't have to do anymore. But this was still what you might call the Full Employment Act for database programmers, right? So when you wanted to do some, query, as we would know it today, you had to write a program that would look up a record and then sort of maybe find an order, and then you wanted to know what was in the order. So your program would navigate kind of through these pointers, and if you wanted to know like what one of the items was, you'd have to navigate off to the item. And so you're basically writing a program that kind of, sort of followed pointers, right? So, you had to follow these structures, and the order in which you would touch these records obviously matters because the record access involved disk I/O, and disks weren't the speediest thing back in those days, and so there, I/O is still a bottleneck in many cases, right? So, put yourself back in time, and it was a big deal. And so whenever you wanted to sort of make your programs run faster or incorporate what was needed for some other kind of query that was going to be accessed, and you had to rearrange the data, you then had to go back and kind of maintain all of your other queries and your other programs, right? So this was not an efficient way to write or maintain queries. And the bottom line is what was wrong with this picture, what we'll see was a disadvantage of this approach, was it was all about the how, right? If you wanted to do something, you had to tell the system how to do it. You had to write the how as a program, not about the what. So application development was very physically oriented and required a lot of effort to build and then to maintain applications. Enter the relational model, right? So Ted Codd came along and said, this is not the right way to be thinking about things. We need to think about things logically. And so he brought sort of a mathematical bent to it, a mathematical logic bent, and said, let's have a higher level model. We'll have relations, which have tuples, which have attributes, or as we call them today, tables with columns, right, and rows. And so the simplicity of this model, as compared to, sort of things before it, made it possible to start thinking about having such a logical model and being able to write queries in a high level in declarative languages, and then have the system figure out what the program under the hood kind of needed to do. So it didn't have to be the application programmer's job anymore to write these navigational programs. Rather, you would write something in a high level language, and then the system would then figure out what to do. So the relational model was the beginning of the idea that we should, as developers, be able to think about our data logically, not physically, say what we want, not how to get it. And so along came declarative queries. Ted brought us an algebra and a calculus for manipulating relations. There was a language developed at Berkeley that was my favorite at the time, called Quell. There was a graphical language called Query by Example. And of course, there was SQL, right? And SQL was brought to us by Don Chamberlain, who, by the way, is a consultant on the side part-time, very part-time. He's retired from IBM for Couchbase. And so he brought us kind of the friendly version of the sort of theoretical languages that Ted Codd was proposing. What came with relational databases were transparent indexing and transparent sort of decisions as to how you want to join tables together and things. And so, as we'll see, we got what's called data independence. You would write your application based on your logical data. So in this case, we have orders and we have items and we have products, and we can think about just having those tables, and we can talk about them in queries without knowing what's under the hood. The system would provide query optimization and execution. And so another one of the real greats in databases was Pat Selinger. She was a researcher kind of at the same time. And so Don and his colleague Ray Boyce designed SQL, and Pat and her colleagues figured out how to optimize SQL queries. And then other benefits of having a logical data model with a set orientation in its query language was then doing sort of parallel query processing became relatively easy in the sense that you're doing set operations, and set operations can be parallelized and subdivided. And then the other thing that came along that was very important was transactions. So the ability to do concurrency control and recovery kind of is another feature that the system would provide that these SQL-based systems then had. And what came out of this was a multi-billion-dollar industry, right? So commercial adoption took a while, right? So they weren't adopted in 1970. And when I got to Berkeley in 1980, they were still a research topic, and there was still controversy as to whether these systems would ever be good enough to take over data management. But over the next few years, commercial adoption occurred. By the late 80s, we had commercial relational databases, and then sort of in the 90s, we had parallel database systems, Teradata, and other companies like that. They were sort of the big gorilla in that space, the real innovator there at first. The relational bottom line was now we moved from a world where people were writing navigational programs to writing queries. And we're going to look more at that to talk about what, not how. So that application development and maintenance benefited from data independence and was logically oriented. And the foundation for this was SQL. All right, so let me sort of give you Relational Data Management 101. This is kind of the first lecture I give to my students at UC Irvine. And so here we have a database. And at the bottom, there are bits on a disk. And then there's a physical schema that describes how those bits are organized and what indexes are available. And then there's a conceptual schema that captures the logical model of data. And the users and the application developers see that logical model of the data. So when they're looking at the data, they don't see the physical stuff that's kind of hiding behind the scenes. They see a conceptual schema. So a little university database would have tables like students and courses and enrolled, with these fields and the fact that this enrolled, this had a student ID and a course ID. This student ID is referring to a student, and this course ID is referring to a course. And so data is related by value matching, hence the name, sort of the relational model. These are relations, but also these relationships are expressed as data values, not as pointers to be, sort of navigated through. What my old thesis advisor from Berkeley would have called the precursor databases sort of pointer spaghetti, in fact. All right, so what's to love about this is we have data independence. Like the stuff, when you look down at it, all you see is logical. You don't have to worry about the physical as you build your application. So let's drill into that idea a little bit more. So suppose we have a student, right, who wants to know, hey, tell me about the course computer game design, right? So if they spoke SQL, to the IT system in the university, all they would have to do, or the application that serves them a web page has to do, is to say select star from courses C, where C.name equals computer game design. That's SQL, right? So the student or the application supporting the student says what they want, right? Not how, and the result comes back. And so you ask the question, you get your answer, right? And again, what, not how, right? So thank you, Ted Codd, for saying this is the way we should see our data. Thank you, Don Chamberlain, for taking Ted's theory languages with Greek symbols and turning them into something usable, which is the SQL language, right? So that developers can now, build their applications like this. And so if you think of a web page that sits behind this, that's got a course name parameter, and the student fills in the web page, and that's the query. End of story. Much simpler for application developers. All right, under the hood, this whole idea of data independence and what, not how, right? So, it took some amount of time to get the answer. And if we weren't happy with the system's performance, we could tune it up, right? So independent of, without worrying about the fact that we're doing this under the hood, the DBA could create an index on course's name. And so then when we run the query, we'll get an answer much faster, because now the system can go, oh, look, I can look that thing up in like a quick index lookup. And this is the idea of data independence, right? So we made this thing run faster by sort of transparently creating an index under the hood. The application developer didn't have to change the application at all, right? It just runs faster. And this is what Ted Codd said. We should think about data this way. Data independence, when I teach introduction to databases, it's like the most important thing that I want the students to take away. All right, well, what about more complicated queries, right? So we have our analyst who wants to, sort of information about, for, the computer game design class, how many students are enrolled. And so the SQL query is a little bit more complicated. You run that query, maybe it takes a little bit longer to run that query, but you still say what, not how, no programming required. And then we could do things like at the physical level, if we wanted to speed that query up. Okay, we could create an index that helps to link courses with enrolled, for example. Right. And the thing to note is under the hood, there's a whole lot of machinery happening, right? There's this whole database system with query optimization and relational operators and a query plan, right? And so when that query comes in, stuff happens, but all the developer of the application has to care about is you ask this question and you get your answer, right? Again, what, not how. No programming, just write queries. All right. And the other thing that's worth noting about the relational world is, the language is kind of independent of the platform, the hardware, the details of what it's running on. So you can run it on your laptop, right? And it might take a little while to give you your answer, but you get your answer back. You don't, you've said your query and you get your answer, right? So if you're not happy with that, then, you should buy a bigger computer. So you run your server and, now your answer will come back, even faster. And if you have a big university, where, I don't know, Ohio State, let's make up a big university, then you have a data center with a cluster and you run that query and you get your answer even faster, right? So what's happening here is that the whole system is also scale independent, right? Same question, different hardware, faster answer. All right, so let's just summarize what we've learned kind of here, sort of sitting in around 1970 in the DeLorean looking out at the relational world, right? So the Spartan simplicity, the simplicity of the relational model, rows and columns, tables, that's all you have to know, made it possible to start tackling the opportunities and challenges of a logical data model. So we had declarative queries, transparent indexing, query optimization execution. We could parallelize this in data warehouses with technology like what Teradata developed as an example, transactions, concurrency control recovery, also to make it easier for application developers to not worry about what happens when the system fails or when there's concurrent access to data. So all those things are very important characteristics of databases, and they were developed in the world of SQL. Right. And again, this led to a multi-billion-dollar industry. SQL has been extremely successful. And the reason is what, not how. Logically oriented application development and maintenance, a.k.a. data independence. But there's some stuff missing, right? So flexible schemas and horizontal scaling are two things that are really important in today's world, and we'll talk more about that. And dealing with the new data, right, on that timeline that we had before. What about that? All right, so that's the relational world. That's why it was successful. Let's look at the NoSQL world, and let's look at Couchbase Server, and then more specifically at 7.0. All right, so NoSQL is like the post-relational era. I actually teach another class called Post-Relational Data Management, where we talk about other technologies beyond relational. Right. So the relational world was 50 years old, right? We were back in 1970 and then in the 80s, commercially in our DeLorean ride. But the relational model, because it's over 50 years old, is pretty rigid and pretty set in its ways, right? We old people can be rigid and set in our ways. And maybe I'm even more than, 60 years old, right? But the driving use case for the relational model was 1970, roughly, business data. Right. Back then, people thought, the world was flat, right? So it's a flat world. Data is flat. And, first normal form is what that's called technically in fancy relational database language. But basically, it's tables with rows and columns contain single values, right? Data characteristics were also static. Schemas were a feature. It could tell you what's in your database, and they didn't change very often, right? An employee is an employee. And, 2 years ago's employee is today's employee, probably, right? In terms of the rate at which things were changing back then. But the world has changed, right? It's evolved a little bit in the half century, right, since the relational model was born. Applications today are way richer, right? Application objects, right, they're like no longer flat, right? So it's not a flat world. We have orders and orders have line items and we have products and, some products, might have a power and some other products might have a size, so application objects are not only like nested potentially, but they vary from one to the next. The deployments, right? The applications that people are building today, it's not, 50 bank tellers talking to a mainframe. It's the world connected to, a web server, right? That needs to support a gazillion users, right? The application schemas, like the requirements are changing all the time. And you need to be able to, add new information about a product and not have to wait, for committee approval and for a big, bring the site down and make a big change, right? You need to evolve application schemas naturally, incrementally, and painlessly, and online, right? There's, it's a 24/7 world. And so these are some of the requirements now for dealing with data in the modern era, right? We need to deal with this. Right. And so, what people would say, back in the days when we were looking at object databases, which are not so different in some ways, sort of spiritually from what we're doing today with JSON data. It's, think about it. It's like to put something, in your garage. If you drove in, you'd have to put your tires on the tire rack and your wipers on the wire rack and your seats on the seat rack. You have to disassemble your car, right? And then, in the morning when you want to drive out and go to work, you reassemble your car. I mean, what's wrong with that picture? Right. And we don't really want to have to do that with our data. We'd like to be able to store our data in its natural form and query our data in its natural form and let our data's natural form evolve over time. Right. So we don't want that garage model for our data anymore. It's not good enough. Along comes Couchbase Server, which you might also call the Couchbase data platform. Right. So here we have sort of an artist conception of the architecture of Couchbase Server. We've got the data services and data service nodes and a query service node and an index service node. Very small cluster, just as an example. Analytics service, eventing service, right? And then it's connected to this is one Couchbase cluster, and you can sort of vary the number of nodes that things live on and so on. Right. Couchbase Server started out, sort of like the company, doing distributed caching, and then it's distributed caching with persistence, and then it's a little bit of query. It has grown from being a distributed key value store into being what I'm going to argue is a uniquely capable, highly functional, next generation, true database platform, like the database platform today. And I'll try to explain to you why I think that's the case and why I think it's unique. All right. So NCL is the language that you speak to Couchbase Server in. In the open source world, the language is actually referred to as SQL++. It's essentially take SQL, allow it to deal with nesting, relax its rigidity about schemas, right? So it's an extension of SQL that is designed to deal with modern data. It's not for a flat world anymore. And so you can use NCL to talk to the query service. You can use NCL to talk to the analytics service. And so essentially, when you're building an application now, you build your application in much the same way that you would build a relational application, all right, and with much the same benefit, right? So you say what, not how. And NCL is the language, SQL++, sort of under again, the open source name for that language. This is a declarative language. Every bit is declarative as SQL, and every bit is valuable for simplifying application development as the origins of SQL, because now we can do what we used to do on flat tables against our much more rich data. All right, so that's kind of the logical view of sort of what's going on there. Let me just tell you a little bit about what's under the hood of Couchbase Server with respect to implementing NCL. So there's two services, the query service and the analytics service. And so when you want to do something quick and get it done fast, and you want to do it for thousands and thousands of users, you use the query service. When you have your harder questions, you use the same idea, but you direct it to a different endpoint called the analytics service. And DCP, the data change protocol, was sort of inside Couchbase clusters, keeping information about what's in the database, what's in the data service, sort of known to the index service and the analytics service. So at the bottom, what you see is this sort of DCP strip. Think of it as sort of an event bus, where when something gets added to or removed from or changed in the data service, the index service gets the memo and the analytics service gets the memo. And what's going on with the analytics service is it's maintaining a shadow copy of the data, and I'll tell you why in just a second. All right, so we've got our user who wants to do something quick, wants to ask a quick question, right? So the user wants to know, how much money does Robbie make? So select value salary from EMS where name equals Robbie, and shoots that at one of the query service endpoints. And what that endpoint does, it sort of figures out how it wants to run that query, and it goes and talks to the index service. Hey, what's the object key for the employee named Robbie? And the index service responds. And then given that object key, the query service asks a quick question of the data service saying, hey, can I please have the object with this key? And the data service says, sure enough. And then back comes that object, and the query service can then answer the question, right? So Robbie makes 1.8 million. I'm sure that's, a low estimate of what he makes, right? But so what you notice is it's kind of a point-to-point, very fast, very efficient execution of that simple request. Suppose you have a more complicated request, right? Your analyst is over here wanting to know something a little more complicated. Maybe the CFO wants to know, hey, how much money am I spending right now on my employees, right? Where it seems like I have a big drain, right? So where's the money going? And so that question gets asked of the analytics service, where you can safely ask such questions and get the answers without perturbing the service that the query service is providing to the OLTP-like applications. And so your OLTP stuff is kind of on the left, your OLAP stuff is kind of on the right. And so what that user does is they pose that question to analytics. Analytics does some magic that you can hear about in another Connect session, called MPP, massively parallel processing. It basically sort of distributes that request across the nodes of the analytics service, and the analytics service, those nodes collaborate to compute the result in parallel and then give the result back to the analyst. Okay, so there are actually two engines under the hood. This is a feature. This is not a bug. This is a feature because one of the engines is designed for the smaller, fast, high volume requests, and the other engine is designed to do the heavy lifting. All right, so that brings us to Couchbase Server 7.0. What's unique about it, and why am I, sort of here trying to tell you this story? So if you look at Couchbase Server 7.0, what you see is it has a bunch of features now that organize data in very much the same way as a relational system. So it has the notion of scopes and collections. And so collections are roughly like tables and scopes are kind of like schemas, only they're allowing for richer data. Has a bunch of enhancements in Couchbase Server 7.0 relative to sort of query processing. So now there's statistics being maintained and cost-based optimization, and you can even ask an index advisor for advice as to what you should do behind the scenes to make things run faster, and cut and paste its advice, and your system will start running faster, much as in that slide that I showed you from the relational system before. There's also support in 7.0, super important new feature, nickel transactions. Right, so now you can write multi-document, multi-statement transactions in nickel with the keywords that you're familiar with from the world of SQL. Begin, commit, save point, rollback. Right, so you can write your transactions here like you would have in your old comfortable world of relational. And there's just a bunch of cool stuff that's been added to the nickel language. User-defined function support, won't go into the details. Advanced analytics support, again, won't go into the details. But it's a rich language with now support for UDFs and support for windowing. Actually, that was not new in 7.0, but that was there. But very important for doing business analytics, and new features to do things like cube, roll-up, and grouping sets if you're directing your query to analytics and you want to do those kinds of advanced analytics. Right. So if you think about this, I kind of like to think that if Ted were still with us, so Ted Codd passed. I never got to meet him, unfortunately. So he's up in in the cloud in heaven. He'd be looking down. I'd like to think of him looking down, going, "These guys get it. Like data independence. That is so important. Like they heard the message. They got the memo." Okay. So that's what Couchbase Server 7.0, in my opinion, brings to the table. Let me talk a little bit why I'm hopeful about that, and a little bit more to emphasize the readiness of Couchbase Server for tackling, sort of the real next generation data management problems. So this is, I'm going to tell you just a very brief story, and I can send you the paper if you want, about a benchmark that we did recently called CH2 that's inspired by TPCC and TPCH, presented at a symposium a couple months ago of the Transaction Processing Council's technical committee. And what the benchmark does is it runs at the same time transactions and queries. And so on the left, you see, the 5 transactions that those of you who have heard about TPCC might be familiar with. And on the right, you see what would be 22 queries running in streams inspired by TPCH, but against the C schema. Those of you familiar with TPCH know that it's an industrial standard for, these are the kinds of query systems need to do. Let's see how fast the systems are. And this is a benchmark for HOAP, Hybrid Operational Analytical Processing, which Gartner calls HTAP, Hybrid Transactional and Analytical Processing. Basically, the system is trying to do all this at the same time, and the benchmark is designed to see if it's up for the task. So we're running a workload with a bunch of parallel streams running, picking one of those transactions and then running those. So there's a whole bunch of threads running transactions, and then there's a stream of queries, decision support queries also running. So how did this benchmark go? So let me tell you a little bit about it. So the benchmark transactions were written and they look like this, right? And the thing to notice about this is you're writing your transaction in nickel. This is the NewOrder transaction in nickel. It looks a little different way at the bottom because orders and line items are not separate anymore. Orders have line items in them. And so you're allowed to have nested data. And so that last thing looks just a teeny bit different, but this is all nickel. You're basically writing a SQL style transaction, right? to do this. So you're doing this as though you were dealing with a relational system, but you're not. It's for NoSQL. What about queries? So the data on the left, is an example of an order object, which has some nested order lines in them. The query on the right is, one of the queries from the mix. It's a high-level query. It says what, not how. What happened when we ran this benchmark? So we did a bunch of experiments kind of with the benchmark. And so what you're seeing on the left is some results. I'm not going to go into the details, but how fast were the transactions with 4 query nodes or 8 query nodes? And the query node had the query plus the index service plus the data service deployed on it. And the thing that we learned from that was if you double the hardware, your transactions are running twice as fast. So we demonstrated the scalability, the horizontal scalability of Couchbase Server's transactional support. We also then looked at the question, okay, what if we try to run queries at the same time? Surely that has to be bad, right? We weren't actually thinking that, but you might imagine that it could be. And the answer was it wasn't. The performance that the front end was able to deliver for that transaction mix did not get reduced when a heavy query was running in parallel with a stream of 22 queries over and over again. You get essentially the same performance, and you get the same performance scalability when you increase the number of nodes from your on the query side. You have effective performance isolation. So the analysts can ask their questions and do their business without interfering with the online users. What about the analysts? So what happens? What if they want their queries to run faster? So we also looked at having 2 analytics nodes, 4 analytics nodes, and 8 analytics nodes. Again, we won't go into the details, but what we saw was linear query speedup. 4 nodes was twice as fast as 2 nodes. 8 nodes was twice as fast as 4 nodes, right? And so what we're seeing here is proof of scale independence, right? You can scale the transaction side, you can scale the query side, you can scale them separately. You can ask the same question, and it doesn't change. It's not like, okay, now I have 2 collections, and so one of them's too big, and I can't use this feature anymore. Same query runs at these different scales. All right, so getting close to the end here. What's not to love about that? Let me sort of try to wrap up how I see this, today. So once upon a time, we had a world where, Couchbase in the enterprise was about operational stuff. And so on the left-hand side, you see, sort of a shopping application and a customer call center application. And, whoever this company is that we're sort of mythical company we're looking at, made some good buying decisions, right? And so they have Couchbase for those too. They're doing some stuff with social media. And for whatever reason, they purchased, some competitors' NoSQL database. Well, who knows why, but, we might argue that wasn't the best decision, but we have other kinds in this enterprise. And then, there's stuff, older data that's living in relational database systems. So that's kind of the front, if you will, of the enterprise data story. But we all know that there's more to it than that companies want to do analytics, right? And so they also have a data warehouse, perhaps, or nowadays they may have a data lake. Where they dump their raw data and then they later ETL it into the warehouse. And on the right-hand side, we see a bunch of analysts kind of waiting to be able to do their business and figure out what's going on using BI tools, visualization tools, or data science techniques, machine learning, whatever they want to do. They're on the right-hand side kind of waiting for the data to drift across the data lake and or be in the data warehouse. So what has changed with Couchbase and the way we're approaching kind of this enterprise world? So nowadays, as of the current Couchbase server, you're able to take those operational databases and you can have the analytics service either running on the same nodes, or actually you can have a separate sort of consolidated analytics cluster if you'd like to, that allows you to do analysis on that data using NoSQL in real time, right? So you can ask your questions on the data, which is in your operational database, right? So what you see sort of here in the picture, sort of near the gold, the gold disks, which are representing the analytics sort of consolidated cluster, you see analysts that used to be on the right, like waiting until tomorrow or whenever the data was going to be available. Now they're able to run their queries on the left. And so able to get the answers on the current data safely because there's HOAP. And the other thing you notice is the little no ETL symbol there. They're running their queries against the data, the same application model, the same nested data with variable schema that is in their operational data. They don't have to first set up ETL and restructure that data to put it in a warehouse to start asking questions. So if they want to know what's going on now, they can ask what's going on now, but they're using NoSQL. They're saying what, not how. right? And the applications can be built now using NCL plus the transactions in NCL, just like you're used to from the old relational world days. Okay. And so also just sort of side note, right? If you need to sort of reach into your data lake and combine some of the stuff that's maybe there with your current data in order to get some more insights, you could do that too with Couchbase Server. So I think where that brings us is a world where it makes sense now. This is like the time is now to think about replacing other things that you might be doing with Couchbase. And why does that make sense? Because now you can bring that what, not how efficiency, that what, not how easy to maintain this with NCL and transactions being available in Couchbase Server 7.0. So I think we've gotten to a point where it makes sense to revisit some of those other decisions and to think about, like, for new applications, using this technology that you don't have to go to relational to be able to do your transactional stuff and to, ask things in SQL. You can do it in this world. So I'd like to think, as I sort of indicated before, that, if Ted was in the cloud looking down, he'd be like, yes, they got the memo. They understand that the benefit of database systems is a logical view. Don't, sort of have your developers have to think first about the physical. That was the world before Ted. Ted changed the world. And we need to remember that, right? Don't have your developers, have an experience where once their data gets too big, some of the features don't work anymore, right? We need scale independence, right? We want this ability to write our application once and have the system scale and only worry about the logical. So I'd like to think that if Ted were in the cloud, he'd be looking down and he'd be happy, or maybe he would be, exploring Capella, right? Which is Couchbase in the cloud, as long as he's up there, right? So anyway, let me sort of wrap up here. So the message I'm bringing to you is that there's a reason that databases have been so successful, and Couchbase gets that. I think it's really important, right, to remember, why it is that databases were successful. Because if you forget, you're going to be back in a world that's physical again, and where developers are not efficient again. And so that's the message. That's the benefit of knowing history, right? Let's not repeat the mistakes of the past, the BC mistakes. Let's benefit from what, not how. And what is, I think, very cool is that Couchbase Server, as of 7.0, really brings those benefits to the table. So that's my story, and I'm going to stick to it. All right, I'd be happy to talk to you more about this, and I will in the sort of online post session. If you want to find me, you can send me email. It's mike.curie@couchbase.com. I'd be happy to share more details of any of this stuff that you want. Encourage you to go look at some of the other Connect sessions that talk about that benchmark that I mentioned, that talk about what's under the hood of analytics, that talk about some of the new stuff like Python UDFs and things like that. Again, please explore Connect, look at all of Couchbase Server 7.0's features, and thank you for listening. And what I'm going to do is go off and take your questions online if you have any. Thanks.